Hi, we're Group 9, and for Challenge 6, we used a photon. So the photon is used to get localization points, and to do that, we use access points. These access points are Wi-Fi access points that's already provided in the building. And we use a router to connect to these access points, and the router is connected to the photon as well. We use KNN to classify our localization, and the data is pushed to a web server so we can visualize the position. So in our particle photon, that's where we're scanning the Wi-Fi access points, and we use Wi-Fi.scan to get all the access point data. So we parse that to a string Wi-Fi data in this format, so SSID, BSSID, RSSI, and a new line, and we set that to a variable, and this variable is sent to the KNN Python script.
In order to train our KNN data, we had to collect 9 samples for every region, which we divided on the top half of the floor into 24 different regions. These regions were evenly spaced on the sides of the halls, as well as the top and bottom of the east and west side of photonics on the 4th floor. The way we've set up our photons, we actually laid them out so that we collected 3 samples for the bottom, left, and right of the region, the center of the same values, and then the top. So we had a nice box of sample regions that we could then average together. The way our training data goes is we retrieve all that training data from the photons, we clean it up, and then we format it for our KNN algorithm, which runs in Python. So as you've seen from before, we accept a SSID, a BSSID, and an RSSI value, and this just the 2 values we're really interested in are the MAC address of the router and then the value that was read in that region. So this happens many, many times. The first thing we do is that we order it by region. So if we're in region 1, we want to have a tuple of tuples that basically, a list of tuples that basically has these 2 values, and this is one for every single sample. So we aggregate all the samples together. Once we have our regions collected, we take an average of our 9 readings on that region, which contain about 1.8 to 3.6 thousand total readings. And this gets aggregated into a tuple of tuples for each one of these samples. So we should have 9 tuples for each region. And then this value gets sent over to KNN for processing.
So for our localization algorithm, what we used was KNN. The way it works is as you're walking around, since we use photons, you're able to pick up a bunch of beacons, and this is actually an underestimate of how many beacons there are. So these are the beacons, and this is the range that they reach in. So let's say you're around here. If there's a beacon here that has a range of, let's say, maybe bigger than all these other ones, you'll pick it up here and here, and then since as you're walking around here, you'll pick up on average about 9. But then if you move here, you'll also pick up an average of 9, but they'll be different BSSIDs. So the way we handled how to calculate the root mean squared between them was that we only compared two. So for example, if you have a training vector that has all these averaged BSSID and RSSI values, we compared, and if the BSSIDs match, then we only add that to the distance. And if it's not in it, then what we do is we actually increment the distance or the root mean squared by 200 to show that it's very unlikely that it's in that region because it wasn't able to actually pick up the BSSIDs. And this is done for every sample in real time compared to every single training vector for each sample.
So we're using Python Flask to host the server, and what it does is it receives a refresh from the JavaScript in the HTML side, and when it receives it every 1 second, and when it receives that, it triggers the KNN function, and which will calculate what region it thinks the photon is in, and it will send that region number to the HTML side. From there, the HTML will calculate the coordinate based off of the region. So region 27 is our origin, and each grid space is about 65 pixels. So from there, it calculates, so 26, since that's one grid away in the X direction, it will add 65 pixels, and so on. So as you can see, this is at region 35 right now, as marked by the tape. So when we pick up the photon and move it, the website should update. And so now we have reached the corner, and as you can see, this is where we are at.
This is the other corner.
Mhm.
So if Santiago goes and we stay here, and then he can go around the hallway, and we can see where he is at.